Hey everyone, hope you're doing well. In this video 6.3, we're going to be going over how to prove triangles are similar, okay? And we're not actually going to be proving them though, so breathe a sigh of relief. All we're going to be doing is just kind of saying, what congruence theorem would you use to prove that they're similar? So just reviewing real quick what similar means, all right? Similar means that they have congruent corresponding angles. So angles are the same, all right? And corresponding sides will have the same ratio, and that ratio is what we call the scale factor. So we're going to be talking about this a lot today. So there's actually 3 shortcuts that you can use in order to prove that triangles are similar. The first one is AA, and so these are kind of the same as like what we did with triangle congruence. So AA stands for angle, angle, and what it says is if 2 triangles have 2 pairs of congruent angles, then the triangles are similar. So they only need 2 angles to actually be similar. So what that might look like, let me draw a picture real fast. So we have a triangle right there. We have a smaller one, okay? So let's say, and I'm just gonna make up something, let's say that that's 50 degrees, and let's say this is 35 degrees. So these 2 would be similar if this was 50 degrees and this was 35 degrees. Okay? So if 2 angles are the same, then you can say, okay, the triangles are similar by AA. Okay, and that's kind of how it looks. The other 2 are ones that we've seen before. And so the first one is SSS, which S's stand for side, so this is side, side, side. Now it's side, side, side similarity though, so the sides aren't going to be congruent. The sides are actually going to be proportional to each other. Okay, and what that means is that, they have the same ratio between them, or that there should be like a common scale factor between all the sides, okay? So that's kind of what this is saying right here, all right? If you look at the sides AB matches up with RS, so if we did AB divided by RS, then that would give you, the ratio between those sides. And then you would want to check the other sides as well. So you've also got BC and ST. So you'd want to do BC divided by ST. And then you would also want to do CA divided by RT and make sure that those were the same, okay? So we're going to look at an example real quick. It says it's either DEF or GHJ similar to ABC. So the way that we're going to look at this is we want to match up the sides correctly and see what they are. So the first one that we're going to look at is AB, all right? And AB, so those are the first 2 letters, AB matches up with DE, okay? So that's right there. So that's 6. So to find that ratio, we want to do 8 divided by 6. And 8 divided by 6 is 1.33 repeating. So you can put those in your calculator, but I already know the answers. Next, we want to look at BC. All right. So BC matches up with EF, which is 9. So we want to do 12 divided by 9, which is also 1.33 repeating. And then finally, we want to do AC. All right, AC matches up with DF, which is 16 divided by 12, which is also 1.33 repeating. So because all of the ratios are the same, we can say yes, that those triangles are similar. All right, so you need to check all 3, because if one of them is different, then they don't have that common ratio, which means that they're not similar. So The other one we're going to look at is JHG, and we're kind of going to do the same thing, all right? So if we look here, we've got AB. AB matches up with GH, and if we go to GH, it's actually the same number. It's also 8. So our ratio for that one is going to be 8 divided by 8, which equals 1. Now we want to check the next one, so BC, all right? BC is similar to HJ. All right, now BC is 12 and HJ is 10, okay? So that actually gives us a ratio of 1.2. So because those numbers are different, we're gonna say no, all right, they're not similar. All right, and that's basically what you're doing when you're trying to check with these side lengths, all right? Now the last one that we're gonna go over is SAS. And SAS kind of works the same as SSS, except with an angle in between. So if two sides of one triangle are proportional to two sides of another triangle and their included angle, or included angles, are congruent, then the triangles are similar. So just reminder, right, what does an included angle mean? Included angle means the angle, all right, is in between the two sides, all right? So this is an included angle. This is not an example of an included angle. The angle's over here on the right, whereas our two sides are here and here. Okay, so that angle is not in between the two sides. However, when we go to the last one, this is an included angle. We've got our angle, and it's directly in between the two sides. So it's got to be that included angle in order for SAS to work, all right? So we can just look at this example real quick, all right? We've got 4 divided by 2. That's going to be the same as 3 divided by 1.5. Those are both 2. And then we have the included angle. That's the same. Angle X is congruent to angle M, so this would be yes by SAS. Okay, so that's basically what you are trying to do here. So what you guys are going to do on your practice, all right, is you're basically just going to look at the picture, say whether they're similar or not, and say what the shortcut's going to be, and finish writing the similarity statement. So you don't need to actually write any proofs or anything. Just say, okay, yes, it's similar, and I would use SAS or SSS or AA to prove it, okay? And you'd be kind of checking it by doing the same thing that we were doing up here. So if you have any questions, don't hesitate to reach out to me, and I'll help you out. Other than that, have a great day.